There's a city in southern Italy where the ground beneath the streets has been moving upward for more than 2 decades. And the people living there know it, feel it, and cannot stop it. Not by a centimeter, not by a millimeter, by more than 1.5 meters of measurable, documented, GPS-confirmed vertical displacement since 2005. That is not a geological abstraction. That is the height of a grown adult rising out of the earth, silently, relentlessly, under one of the most densely populated coastlines in all of Europe. And in June of 2025, the earth beneath this city shook with the most powerful earthquake ever captured in the entire modern history of monitoring this region, magnitude 4.6, the strongest ever recorded here. And the critical detail, the one that should stop you, is that these earthquakes are not winding down. They are not stabilizing. According to researchers tracking the seismic data in real time, the rate of events is accelerating at a pace that fits what scientists call a super-exponential curve. Each year, more events. Each year, more energy released. And a modeling study published in early 2026 has now run the numbers forward and arrived at a projection that changes the conversation entirely. If the current trajectory holds, the ground in this region could rise by a total of 4 meters before the early 2030s. 4 meters. And the geological structure responsible for all of it is not the volcano the world has heard of. It is not the one that buried Pompeii. It is something older, something larger, something that most people walking through its landscape have no idea they are standing inside. The Italians call it Campi Flegrei, the Phlegraean Fields, a volcanic caldera 12 kilometers wide. And at this exact moment, it is recharging. Most of us know Vesuvius, the mountain east of Naples, the destroyer of Pompeii in 79 AD, the silhouette that defines the bay, the textbook image of a dangerous Italian volcano. That knowledge, while accurate, has produced a blind spot. Because Vesuvius and Campi Flegrei are neighbors, separated by the city of Naples itself, and in almost every meaningful geological metric, Campi Flegrei is the more dangerous of the two. Not a more dangerous version of the same thing. A categorically different kind of volcanic system, operating at a scale that puts it in a class of structures most people do not even know exists. Vesuvius sits to the east of Naples. Campi Flegrei sits to the west. Both are classified as active volcanoes. Both have erupted within documented human history. Both are monitored continuously by one of the most sophisticated volcanic surveillance networks on Earth. But they are constructed completely differently, and that difference is everything. Vesuvius is a stratovolcano. It has a shape. A summit you can see from the bay. A conical profile rising to over 200 meters. You can point at it from a boat and say, there is the danger, and be essentially correct. Campi Flegrei has no such shape. It has no mountain. It has no summit. It has no crater visible from the street. What it has instead is a bowl, a 12-kilometer-wide collapsed depression in the earth. And that bowl is filled not with barren volcanic rock, but with vineyards, beaches, Roman ruins, apartment buildings, fishing harbors, thermal spas, and approximately 500,000 people who live their daily lives inside a structure that was created by 2 of the most violent geological events in European history. The towns of Pozzuoli, Boccoli, and Monte di Procida sit at the heart of the caldera. The western neighborhoods of Naples extend into its eastern rim. The entire western metropolitan fringe of one of Italy's largest cities is built directly on top of an active volcanic system that does not look like one. That is not a coincidence of urban planning. That is centuries of human civilization growing up around landscape that gave no obvious warning of what lay beneath it. Rolling hills, warm coastal waters, the smell of sulfur. In places, yes, but the region has always smelled like that, and people learned to ignore it. The reason Campi Flegrei does not look like a volcano is because the volcano is not beneath it. The volcano is it. The entire landscape is the volcanic structure. The hills, the harbor, the plains, the coast, all of it sits inside the collapsed remnant of a magma chamber that has emptied catastrophically, not once, but twice. 40,000 years ago, Campi Flegrei produced an eruption that geologists classify as one of the most powerful events in the entire quaternary record of European volcanism. The Campanian Ignimbrite eruption carried a volcanic explosivity index of 7, placing it among a small group of eruptions in all of recorded geological history that fundamentally altered the climate and ecology of the planet for years afterward. To understand the scale, consider that the 1980 eruption of Mount St. Helens, which reshaped an entire American landscape and killed dozens of people, carried an explosivity index of 5. Every single step up that scale represents an eruption approximately 10 times more energetic than the step below it. The Campanian Ignimbrite was not 10 times more powerful than St. Helens. It was 100 times more powerful. The eruption released approximately 200 cubic kilometers of volcanic material into the atmosphere. Ash from that single event has been recovered by geologists in sediment cores drawn from sites across the full width of Europe, across the Russian steppes, and into parts of North Africa. One eruption, one event, ash that fell on every corner of the continent. The climatic aftermath likely persisted for years, cooling temperatures, disrupting growing seasons, accelerating environmental stress on already vulnerable ecosystems. A body of scientific literature has explored the possibility that the Campanian ignimbrite eruption played a direct role in the collapse of Neanderthal populations across Europe. The specific causal chain remains a subject of academic debate. The timing, however, is undeniable. Neanderthal populations were already under pressure from climate shifts and the arrival of modern humans. The Campanian ignimbrite eruption arrived at precisely the geological moment when those populations were at their most fragile. Whether it delivered the final blow or simply accelerated a decline already underway, the eruption was large enough, violent enough, and consequential enough that researchers are still debating its effects on human prehistory 40,000 years later. 15,000 years ago, Campi Flegrei erupted again in an event known as the Neapolitan Yellow Tuff eruption. This eruption was smaller than the Campanian ignimbrite, but smaller in this context is a deeply misleading word. The Neapolitan Yellow Tuff event was still catastrophic across a regional scale, depositing thick layers of yellow volcanic tuff that became the primary building material for Naples and the surrounding region. Walk through the historic center of Naples today, study the walls of its oldest buildings, and what you are looking at is the physical legacy of a volcanic eruption 15,000 years ago. The stone of the city is the eruption. Both of these events produced calderas, which is to say they produced Campi Flegrei. When a volcano of sufficient size empties its magma chamber in a single explosive event, the rock above the chamber has nothing left to support it. The entire surface collapses downward into the void, creating a depression that can span kilometers across. This is not the kind of crater you see at the top of a standard volcanic cone. A caldera is not a crater. A caldera is the scar left behind when the volcano does not merely erupt, but effectively destroys itself from within. The same process created Yellowstone in the American West. It created Toba in Sumatra, whose eruption 74,000 years ago is believed to have reduced the global human population to perhaps a few thousand individuals. It created Ira caldera in southern Japan. These are the structures that volcanologists place in a special category, supervolcanoes, not because they erupt more frequently, but because when they do erupt, they do so at a scale that separates them from every other category of volcanic hazard on Earth. Campi Flegrei is Europe's supervolcano. The difference between it and Yellowstone is not geological, it is demographic. Yellowstone sits in a national park in Wyoming, where the nearest substantial city is hundreds of kilometers away. Campi Flegrei sits beneath a metropolitan region of nearly 1 million people, and the question of what a future eruption would mean for those people is not theoretical. It is the central, urgent, and unanswered question that a growing number of the world's leading volcanologists are now dedicating their careers to understanding. Here is something that makes the current situation genuinely alarming, and it is a piece of history that almost nobody outside volcanology knows. Campi Flegrei has already erupted once in modern historical times, not in ancient prehistory, not in the geological deep past, in the year 1538, within the last 5 centuries, within the era of written records, eyewitness accounts, and surviving historical documentation. And the sequence of events that led to that eruption follows a pattern that bears a disturbing resemblance to what is being measured at Campi Flegrei today. For roughly 3,500 years before 1538, the caldera was geologically quiet. No major eruptions across the entire sweep of the Bronze Age, the Iron Age, the Phoenician trading era, the height of the Roman Empire, the fall of Rome, the Byzantine period, or the medieval centuries. Roman engineers, some of the most practically sophisticated builders in history, constructed baths, temples, harbors, and aqueducts throughout the caldera region. The famous Macellum at Pozzuoli, often mistakenly called the Temple of Serapis, is one of the most cited geological monuments in the world, not primarily because of its Roman architecture, but because its columns preserve physical evidence of the caldera's long-term geological cycles, including bore marks from marine mollusks at heights well above what would have been sea level during the Roman period, evidence that the land dropped and flooded and then rose again over centuries. The Romans built their infrastructure across this landscape because it appeared stable, because across the entire span of their civilization it was stable. Then, sometime in the early 15th century, around the year 1400, something changed deep beneath the caldera floor. The ground began to move upward. The movement was gradual at first, almost imperceptible across a human lifetime, but it was measurable in the cumulative displacement of coastlines and harbors over generations. Over a period of approximately 130 years, from the early 1400s through to 1538, the central caldera floor uplifted substantially. Modern geodetic reconstruction studies have concluded that the magma source driving that pre-1538 uplift was located in precisely the same subsurface plumbing system that is generating the uplift being measured right now. the same magma reservoir, the same general depth range, the same geographic center beneath the western caldera floor. A geological system that had been dormant for more than 3 millennia woke up slowly, spent a century in a third building pressure, and then, in September 1538, opened a new vent in the western section of the caldera and produced an eruption. The eruption built a new volcanic cone from nothing in approximately 1 week. 1 week. A hill 130 meters tall, constructed from erupted material in 7 days, still standing today, still visible from the higher elevations of the caldera rim, still called Monte Nuovo, the new mountain. The eruption was what volcanologists would classify as small by Campi Flegrei standards. The total volume of ejected material was a fraction of what either the Campanian ignimbrite or the Neapolitan yellow tuff had released. But small, again, is a term that requires context. The Monte Nuovo eruption was still sufficient to destroy the villages closest to the new vent. It was sufficient to force the evacuation of Pozzuoli. It was sufficient to kill a documented number of residents who had returned too early believing the eruption was finished, only to be caught by a renewed explosive phase. Small did not mean safe. Small meant survivable at the margins, with extreme loss at the center. And the critical geological lesson from 1538 is not the eruption itself. It is the pattern. Long dormancy, followed by gradual and then accelerating uplift, followed by eruption. That is the documented sequence. And the current episode at Campi Flegrei began in 2005 and has been following that same sequence in real time for 21 years. The town of Pozzuoli sits at the geographic center of the caldera's deformation, directly above the zone of maximum uplift. And what is happening to the physical fabric of that town is not subtle. Since 2005, more than 1.6 meters of vertical ground displacement has been recorded at the center of the deformation zone. Streets that were level have developed visible tilts. Buildings constructed on the assumption of a stable foundation have developed cracks in their walls and joints as the ground beneath them shifts unevenly. Harbor structures that sat at the waterline for generations have been pushed upward, leaving ancient stonework exposed above the sea surface in ways that mirror the Roman-era records preserved in the Macellum columns. This is not geology that reveals itself only in data tables and satellite measurements. This is geology you can walk up to and touch. This is geology that the residents of Pozzuoli can see from their windows and feel when they drive over the deformed asphalt of their own streets. And while the ground has been rising, the earth has been shaking with increasing frequency and increasing force. The years 2024 and 2025 produced the largest earthquakes in the entire modern instrumental record for the Campi Flegrei system, the 4. 4 magnitude event in 2024, then the 4. 6 magnitude event in June of 2025, the largest ever captured since systematic monitoring began. These numbers matter for 2 reasons. The obvious reason is the immediate hazard, the cracked plaster, the frightened residents, the activation of civil protection protocols. The less obvious but more significant reason is what the earthquake data reveals about the state of the system beneath the surface. Researchers analyzing the seismicity in detail have found that the relationship between the ongoing ground uplift and the rate of earthquake production is not a simple, proportional one. If the uplift accelerated by a certain percentage, you would expect the seismicity to follow by a roughly similar percentage. That is not what is being observed. The seismicity is responding more sharply, more nonlinearly, than the uplift rate alone would generate. The earthquake rate is rising faster than the deformation rate. And that divergence, that gap between what the ground is doing and what the earthquakes are doing, is scientifically significant. It suggests that the rock itself is being changed by the process, not just stressed by it. The pressure being generated by the rising magmatic system is not merely pushing the surface upward. It is fracturing the rock through which it passes. It is creating new pathways, new cracks, new zones of weakness through the crust, in ways that change the mechanical behavior of the ground long before any eruption occurs. A 2026 study conducted by a collaborative team from the GFZ Helmholtz Center for Geosciences in Germany, Italy's own National Institute of Geophysics and Volcanology, and the University of Pisa developed a comprehensive deformation-driven earthquake interaction model for the caldera. The model confirmed that the seismicity patterns being observed are consistent with a nonlinear feedback system, meaning the interactions between ground deformation, hydrothermal fluid movement, and rock fracture are reinforcing each other rather than operating independently. Long-period seismic signals recorded beneath the caldera have revealed something particularly revealing about the internal architecture of the system. Researchers have identified what the data describes as fluid-filled fracture networks forming in the upper crust. To translate that from technical language into plain terms, pressurized fluids, a combination of magmatic gases rising from depth and groundwater that has been superheated by the magma below, are actively cutting new pathways through the solid rock of the caldera's crust. The rock is not just being pushed. It is being infiltrated, perforated, and weakened by pressurized fluid migrating upward through newly created fracture systems. At the Solfatara crater, the most active surface expression of the caldera's hydrothermal system, gas emissions have been showing compositional changes over the past several years that are consistent with a deepening contribution from the magmatic system itself. The gases are becoming more magmatic in character. The ratio of certain chemical species in the emissions has shifted in directions that indicate the gas is not primarily coming from the shallow hydrothermal reservoir, but increasingly from the deeper magmatic source below. What the geochemistry is saying, in the language of volcanology, is that the magma is getting closer to the surface, not necessarily in the sense of physically moving upward by kilometers, but in the sense of its chemical signature becoming more dominant in the surface expressions of the system. The scientists interpreting it are among the most experienced volcanologists working anywhere in the world, and the civil protection framework built around their work is correspondingly detailed. Italy operates a tiered alert system for Campi Flegrei with 4 levels, each tied to specific response protocols and evacuation thresholds. The base level is green, indicating normal background activity. The current level is yellow, which is the lowest active alert level, indicating that the system is showing anomalous activity sufficient to warrant continuous enhanced monitoring. A transition to orange would indicate that precursory volcanic activity has been identified and that preparation for potential evacuation should begin. A transition to red would mean that an eruption is considered imminent and that the full evacuation of the caldera must begin immediately. The system has been at yellow since 2012. It has remained at yellow through 3 subsequent years of escalating seismicity, through the record-breaking 2024 and 2025 earthquakes, through $1.6 meters of documented uplift, and through the publication of research projecting continued acceleration into the 2030s. The alert level represents a scientific judgment about the probability of imminent eruption, not the broader trajectory of the system. The scientists are watching a system that has been moving in a single direction for 21 years, while maintaining the assessment that the transition from anomalous unrest to actual eruption has not yet been triggered. The evacuation planning that underlies the alert system is one of the most complex logistical challenges any European government has ever attempted to develop. Moving 500,000 people out of a 12-kilometer caldera through the road network of southern Naples in the time frame that volcanic precursors might allow is a scenario that emergency managers have studied in detail and still cannot claim with confidence is executable in its most demanding form. The bottlenecks are the roads. The exits from the caldera are limited. The population is dense, and the time between the first clear precursory signal and the moment a new vent opens could, in certain scenarios, be measured in hours or less. In 1538, the people closest to the new vent had hours, perhaps a day, of intensifying signals before the eruption began. Some survived. Some did not. The survivors who made it back after the first phase of the eruption and were caught by the renewed phase did not. 500 years later, with monitoring technology that would have seemed miraculous to any observer from that era, the fundamental challenge remains. The question is not whether the warning will be detected. The technology ensures it will be. The question is whether the warning will arrive early enough to move 500,000 people to safety through the streets of southern Naples. What the accumulated data at Campi Flegrei now shows is something that would not have been possible to state with this level of confidence even a decade ago. The system has been in a state of measurable, continuous accelerating unrest for 21 consecutive years. Every previous modern unrest episode ended. This one has not. Every previous modern unrest episode peaked at lower uplift and seismicity values than the current one. This one has exceeded them all. The 2026 modeling projects a continuation of the trajectory that would push the system, within the next decade, into a state with no modern parallel. The geochemical monitoring indicates deepening magmatic influence in the surface expressions of the system. The seismic monitoring indicates that the rock itself is being structurally altered by the ongoing pressurization. The researchers working with this data are not alarmists. They are scientists, trained in the discipline of uncertainty, careful about the limits of what the data can and cannot tell them, precise about the difference between projection and prediction. And yet, the consistency of their findings, arriving from multiple independent methodologies across multiple international institutions, points in the same direction. The system is not winding down. It is building. Whether it is building toward an eruption, and if so, what kind and on what timeline, is the question that cannot yet be answered. And whether the next phase is a stabilization, as the system demonstrated 3 times before between 1950 and 2005, or an escalation into territory no one now alive has seen at this volcano, is the question on which the lives of 500,000 people ultimately depend. The early 2030s, the date range that the 2026 models point toward as a threshold, is not far. It is within the planning horizon of the Italian government's current civil protection framework. It is within the mortgage terms of houses being bought in Pozzuoli right now. It is within the school years of children growing up inside the caldera today, children who have known their whole lives that the ground beneath them smells of sulfur and shakes without warning, and is, slowly, rising. Campi Flegrei has erupted twice at supervolcanic scale in the documented geological record. It erupted again in 1538, smaller but still devastating, after a 3,500-year quiet period was ended by a century of accelerating uplift. Its current unrest episode has now run for 21 years, longer than any of the 3 previous modern episodes, with greater cumulative uplift than any of them, with seismicity that is accelerating non-linearly rather than stabilizing, and with geochemical signals that point toward increasing magmatic influence from depth. Research published in 2026 projects that the current trajectory, if maintained, would push the system to a threshold with no modern precedent before the early 2030s. 500,000 people live inside the 12-kilometer caldera. Nearly 1 million more live in the surrounding metropolitan region. The volcano they are living above does not look like a volcano. It looks like the Italian countryside, because it is the Italian countryside, and because the entire landscape they inhabit is the geological legacy of 2 of the most violent eruptions in European history. The monitoring is real. The data is real. The civil protection plans are real. The uncertainty is also real, and it is total. No one knows if or when an eruption will occur. No one knows if one does occur, whether it will be small enough to survive at the margins or large enough to reshape the southern half of Italy. What is known is that the ground is rising, that it has been rising for 21 years, that it is rising faster now than it was 5 years ago and faster than it was a decade ago, that every metric being tracked by every instrument watching this system is moving in the same direction, and that the people who live inside the caldera wake up every morning in a city built on a geological process they cannot negotiate with, cannot slow down, and cannot walk away from easily, because this is their home. It has always been their home. The Romans built temples here. The Greeks built colonies here. The medieval city grew here. And today, in 2026, a city lives here above a magma chamber that has been waking up for more than 2 decades. And the question that no scientist, no government, and no model can yet answer is the simplest and most important one of all: waking up to do what?